So now we're going to solve it roughly in the same way, except now we're going to have a line. Y equals 8x plus 13 is in the form y equals mx plus b, so that's a line. And this is a quadratic in standard form. And we want to solve this linear quadratic system. We're going to do the exact same thing. We're going to take this equation. So this is equation 1 and equation 2. And we're going to sub 2 into 1. And what that means is instead of writing y, we're going to write 8x plus 13. So 8x plus 13. That's a pretty horrible 13, but I think we get the point. Equals x squared plus 6x plus 5. Now how do we solve things that are quadratics? What we do is we make one side equal to 0. So 0 equals x squared plus 6x. The 8x goes to the other side and becomes minus 8x plus 5. The 13 comes over and becomes minus 13. So 0 equals x squared minus 2x minus 8. And you could use the quadratic formula for this to solve it, or you could factor it. I'm going to factor it because it will make my life easier. So this factors into x minus 4x plus 2, and that tells us that we have two solutions actually. So we know that x minus 4 equals 0, x equals 4, or x plus 2 equals 0, x equals negative 2. And if you had done quadratic formula, you would have gotten to the same two answers. So x is 4, x is negative 2. Now we're not quite done. We then have to figure out the y values for each of these. So we know that, so our options are x equals 4 or x equals minus 2. And we know that from the first equation that y equals 8x plus 13. And so we could just plug these numbers in. So y equals 8 times 4 plus 13, or y equals 8 times negative 2 plus 13. 8 times 4 is going to be, so it's 32 plus 13, which is 45. And this is negative 16 plus 13, which is negative 3. And putting it all together, we know that one solution is 4 and 45, and the other solution is negative 2 and negative 3. Or to put it another way, one solution is that x equals 4, y equals 45, and the other solution is x equals negative 2 and y equals negative 3. And both of these would be solutions to the equation. Another way the exact same one could have been set up. I'm not going to go through the whole solving on this one. I'm just going to show how it would be pretty much the same idea. We could say f of x, we could use function notation. X squared plus 6x plus 5. And g of x is 8x plus 13. And we know that f of x is a quadratic function and g of x is a linear function. And I want to know when something that works for both of them. So I want to know when are the y values the same for the x's. So I could say I want to know when f of x equals g of x. So what x's are their y values the same? And that would mean that x squared plus 6x plus 5 equals 8x plus 13. And then we would go and solve it. And we would find out that the answers are that f of 4 equals g of 4 and f of minus 2 equals g of minus 2. And that's when they're equal.